Good morning. We are here on February 10th for Fission's weekly video chats. Tend to cover technical topics of interest around distributed systems and many other things. We're here today with Geoffrey and Peter, who are going to be telling us about Project Cambria. I'm going to hand it over to them to introduce themselves and take it away. Please do ask questions as you have them. Thanks, everyone.
Peter, you want to go first?
Sure, maybe I'll frame things up a little bit. So Project Cambria, which Geoffrey will kind of go into depth on, is an ink and switch research joint. It was born out of a series of local first development experiments we had, and what we called for a long time the schema problem, which is basically that if you have a distributed system running different versions of software and you're using these weird CRDT document structures where anything can be anything, we were like, well, we have a schema problem. And we kept saying, well, we'll solve it on the next project. We'll solve it on the next project. And then we were working on Pushpin, which is a past project of ours that's written up somewhere. And the pain of putting off this problem became excruciating. Around this time, we'd met Geoffrey through his wildcard project, where he was working on sort of extensibility of web applications for end users, which I think is a fascinating domain as well. It all kind of comes back to this problem of user agency. And we got to talking about how we could find a collaboration around some of these ideas. And over time, that sort of evolved from a schema problem. The idea of a schema is it happens at write time, which is to say, you say, I'm going to prevent anybody from making a mistake and guarantee the integrity of the data on disk by blocking writes that are no good. But of course, in a decentralized system where anyone can change anything, or you can have Byzantine failures where people just write weird data or decide they want to do something different, you can't actually stop other people from writing. And so the genesis of the Cambria was that we were going to turn that 180 degrees and think about how we could read data more robustly. I think that probably frames things up enough for Geoffrey, so I'm going to hand it a much better problem.
Yeah, and just a little bit about me. I'm currently doing a PhD at MIT in computer science, and sort of came at this work from the perspective of thinking about how end users can build and customize software more easily. As Peter mentioned, in particular, I've been thinking a lot about customizing web apps. So, maybe instead of blowing up the web and replacing it with a decentralized thing, which is going to take a little while, can we also do something where we sort of, through browser extensions, nibble at the edges of the problem and store little bits of data locally, and add little bits of functionality to the cloud apps that we use every day. So that's sort of where I'm coming from. And then, yeah, as Peter mentioned, it sort of ended up intersecting with some problems that we could switch into thinking about. And so that's how we started working on Cambria. Let me share my screen. And can you all see that okay? Perfect. So, and this is the work, by the way, that Peter and I did with another collaborator, Ryan, who's not here today. So I'm going to talk about three things today. We're going to start by thinking about schema compatibility a little bit. What exactly does that mean? Why is it hard? And I think one of the most interesting things we realized on this project was how similar the concerns are across contexts that seem pretty different at first. So we'll talk about normal cloud apps and database migrations. We'll talk about web APIs, and we'll talk about decentralized systems and some of the shared challenges that appear in all those different areas. I think someone may be unmuted. Do you mind muting? I think we're getting a bit of background. So part two is going to be, I'm going to show you some demos of a decentralized app that we actually built. And the cool thing about it is that different people can be running different versions of the software, but they can all collaborate on the same data. And we'll show you sort of some of the developer experience we built up to make that reasonable and ergonomic to do. And then last, I'll share with you some of the ideas that went into this library called Cambria that supports that whole experience. And the hope is that you can find some ideas that you can go, use in your own work, whether you're working on a web API or a decentralized website or all sorts of things. One caveat is that this is not like a sales pitch for our new startup where you should go use our tool today. The tool is not great yet. We're chipping away at it, and maybe it will be, really usable in production at some point. But the point here is mainly just again to talk about the ideas behind the work in hope that you find the ideas useful. All right, let's talk about schema evolution and schema compatibility. So I want to start with this picture, which is sort of a pretty typical centralized cloud app architecture that many of you have probably worked with. You have a database, you have a fleet of stateless web servers, and the time comes to do a database schema change of some kind. And in this case, I'm going to use the example of renaming a column. And I've sort of intentionally chosen that example because to like a naive, like me as a new grad developer, doesn't sound like a big deal, right? Renaming a column. And conceptually, it's extremely simple. But anyone who's actually built software in the world knows that a column rename is a terrible idea and is a huge pain. You probably just aren't even going to bother doing it, right? And I think that really points to some of the lack of tooling that we have access to. And it sort of emphasizes the pain of schema compatibility. So in this case, let's say we want to rename this name column to be called title. And we want to get to this point where our database has this blue schema, and all our web servers have that schema as well. If we could take our whole service down for a few minutes, it wouldn't be a big deal. But if we don't want to have downtime, we have to do the whole typical dance, which probably many of you have done. The way it goes is you start with the green schema. You do something to your database to essentially make it support both columns. So you'll probably copy over all the data into a second column, make sure that the two stay in sync and everyone's writing to both. And then at that point, you can switch over your web tier to be blue. And once you have no more green servers left, you drop the green schema and you're left with your new renamed column, right? And so this is sort of, I think, become accepted as just how you do things, but it's a really annoyingly complicated and delicate dance to get right. Next, I want to show a second example. So same picture, but different context. Here we have an API server on the bottom. So you're running a web API. And on the top, we have some clients out there in the world making calls to your web API. And again, we have this schema for our tasks. And our clients are sending us JSON payloads that have some, that assume some field names, right? And again, same problem. We want to do a rename. Oh boy, it's even worse this time because now we have API clients out there and we don't really control them as much. So if we don't want to force everyone to upgrade, this is going to be sort of an even more painful process. So what do? Sort of similar to before, we do something in our server so we can support both. And then we say, everyone, here's a new API version. Please upgrade your client when you want to. And our early adopter goes blue. But this whole time we have to support both blue and green. So you might have some code in your code base that looks like this, probably fairly familiar to anyone who's written production code. You say, okay, we're going to look in the request. Does it have a title? Does it have a name? It could have either, depending on whether they're on version 10 or version 20. And again, in this case, it might take a really long time for that green to go away because someone just hasn't bothered upgrading, and we don't want to force them to move along, right? And in fact, this process just keeps going. Soon we want to make another change. Now we have a red, and what's happening is our server is sort of growing in complexity to support all these different clients that could be out there. All right, third context, or actually, sorry, before that, one thing I wanted to mention is there's a really nice approach that Stripe has taken to this problem, which we were sort of inspired by and is linked to in our article about this work, where what Stripe did is they said, okay, we don't want to force people to upgrade, but we also don't want our server to get so entangled with compatibility code. So what we're going to do is we're going to add this layer in between, sort of on the outside of our service, that takes someone's API request and passes it through the stack of transformations and turns it into a request that looks like the current version of our code base. So our code base only thinks about the current version, and all the compatibility stuff is in this separate place. And that's, I think, a really good idea. There are some kind of limitations to the way they implemented it that we'll talk about more. But this is one of the key ideas that we're going to talk about today. Okay, finally, third context is now you're in a decentralized system and things have gotten even worse. So what we have here is you have three peers. They're exchanging data with each other, editing shared data. And we start out all of them agreeing on the schema. But now there's not necessarily a central authority that can decide what the current schema even is. right? So what happens if two of our peers simultaneously decide to change the schema in different ways? In this case, they just renamed the column to two different names. And that might be a developer testing out a dev branch. It might be people forking the code. There's all sorts of things that could cause this. But at this point, it's become really hard to reason about all the schemas that might be out there in the world. And as Peter mentioned, if you're writing this kind of code for this kind of decentralized system, and you don't have any sort of schema validation, you're just accepting JSON blobs off the wire and hoping that they match the shape you want, things are not going to go well. You will end up with all sorts of bugs in unexpected places. The reality is there is a schema, or there are schemas. It's just a question of whether they're written down anywhere and whether you actually have a coherent layer that deals with them, right? And so to zoom out a bit from these specific contexts, I think the interesting, we notice some shared patterns, right? Many systems need to maintain compatibility with multiple schemas at the same time. That's a core challenge that appears in lots of places. It's really hard to think through this stuff by hand. You really need tools to help you. So, anyone who's worked in a statically typed language is familiar with the benefits of having your tools help you reason about the shape of your data. And third thing is that we noticed there's many common kinds of schema changes that happen in all sorts of contexts. There's adding and removing columns. There's renaming, or fields. There's renaming fields. There's all sorts of typical kinds of value conversions that occur. For example, you thought you needed one of something, and then you actually realized you needed many of them. So you switch from like a value to an array of values. Things like this there are these recurring patterns. Yes, there is a long tail of weird stuff that happens too, but there's an 80% of vanilla typical schema migration stuff. And so what we wanted to do is looking at this shared problem that occurs in so many places. We wanted to develop a prototype tool that could imagine what would it look like to actually have good tools for developers to deal with these problems in a more principled way than just like throwing a bunch of if statements throughout your entire code base.
There's a great paper, which we linked to again in the Cambria article, which describes this as shotgun parsing, because by the time you get through with it, your code is just like riddled with little like tests for different types all throughout the system. And actually, notably also, I don't think you have protobuf in here, but like protobuf and tools like that, the long run version of adopting these tools is, sure, yeah, you can add and change new fields in your protobufs, but you can only add optional fields. So eventually, after a few years or a few dozen schema migrations, you have a data structure that is basically just all optional types. And then you have to decide in your code, which of these fields is still relevant and current? Which of these fields am I going to read? And then anytime you want to check any value, you have to see if it's there first. And so you kind of wind up like with a typeless data system anyway. Yeah, surely we can do better.
Yeah, I think we found another fun example where we were looking through the GitHub API because we were trying to use that as an example of JSON payload. And they've done the smart thing of not making backwards incompatible changes so they don't break the client. But what that means is that they have one field for the assignee of a GitHub issue, and then they have another field that's an array of assignees of a GitHub issue, because presumably they used to only be able to assign one person, and then they added the new feature to assign multiple, but they can't remove that old field, right? And so I think you see this all over the place. Seasoned developers know how to be smart about, at best, people avoid making breaking changes, but that doesn't really leave you in a good state at all. It just leaves you in this mess of cruft.
Permanent complexity, yeah. And notably that change, at first I was like, oh, maybe this is a recent transition. No, they released this feature 5 years ago. It's never going to change. This pain is now baked in permanently.
And again, is that better than if they just removed the old field and broke a bunch of old clients? Maybe, but it's just neither option is great. So next I'm going to talk about Cambria, but I guess before that, this might be a fun time to ask any questions or comments from the audience.
Keep it rolling.
Okay, let's go.
Jazz hands. You're just talking about fixing the entire industry. Please.
Yes, we're going to give it a shot. So what is Cambria? Cambria is a TypeScript library, and the goal is to help you manage schema compatibility separately from application logic. So the kind of contract you're working with here is you need to give Cambria a couple things. You need to say, here are some data translations. You essentially write little mini programs in this domain-specific language that specify how you want your data to change. They're called bidirectional lenses because the neat thing is that you can write one translation program and it doesn't just run in the forwards direction, it can also run backwards. So you kind of get both directions, upgrading and downgrading in one nice package. And we'll show some examples of sort of what that actually looks like. The second thing you give Cambria is this graph of, you say, here's all my schemas and how they connect to each other through those data translations. Then what you get back from Cambria is the following. Cambria is going to on-demand translate all your data at runtime. So you have data in one schema, you want to be in another schema. Cambria is able to run through your data translations and migrate that data for you whenever you want, sort of on the fly. It also is going to give you TypeScript type definitions that correspond to the schema you're working with. And it's also going to give you JSON schema definitions, which is essentially a JSON document describing the shape of your schema. And the reason that's important is that that's actually checkable at runtime. TypeScript types can't be checked at runtime. They only check at compile time. And we'll talk about why that's important. But basically, the intuition is you need to be able to both reason about the shape of your data when you're writing your code in your IDE, and you better be able to reason about it when you're about to pick a document up off the wire and you're hoping and praying that it's in the right shape. So you need both of those outputs. And finally, a fourth thing is we integrate with the auto-merge Crdt, which we'll talk about more, which helps provide conversion, editing, and decentralized systems. And the neat thing is, basically, because all of these artifacts are coming from one specification of how to translate your data, it sort of saves you a bunch of work by sort of generating all this stuff from one source of truth. And what we were hoping to do is produce something that would be useful for the local first apps that InConSwitch was building, but also applicable in these other contexts that I just talked about. And so we'll sort of walk through that as well. Peter, did you want to add something? Were you unmuting?
Yeah, I was going to say, where you see bidirectional lenses, many of us have actually had practical hands-on experience using something akin to bidirectional lenses in active record migrations and the like, where when things are going well, your migrations in many data management tools are bidirectional already, right? You don't have to write an up and a down. You just write like an alter column or whatever. And the idea is that you could do a one-time, one-off migration automatically in either direction for that. Now, practically, those are conceptually good, but operationally inadequate because, if you are running a large-scale infrastructure and you go and just run that like alter column, one, it will lock your entire database and prevent anyone from reading the table for a while. Two, all of your deployed web clients will catch fire, explode, and start 500ing. And three, it will take like days potentially to rewrite that massive table, so you're just going to be hard down. But the concept is right. It's just that the nature of doing it as a one-off, on-demand migration is no good. But so when you see bidirectional lenses in domain-specific language and you think, boy, that sounds complicated and like a lot of nonsense, you're literally already doing this with schema migrations for your SQL database. We're proposing simply moving it from the storage layer up to the read time. So I'll let you take it, Jeff.
And so, yeah, to make all this I know sounds sort of abstract, and so I'm going to show a demo now of an app that we built to sort of make this much more concrete. We actually, we co-developed Cambria alongside building this sample app because we wanted to make sure it actually did real things. And so we built this issue tracker, a to-do list task tracking app, basically. And we built it with this architecture that Peter and InConSwitch had worked on previously for the Pushpin project. And the rough idea is the following. You have each user running a little Electron app on their local computer. And it's storing data locally in a document managed by the auto-merge library. And you can take your computer to the park, work offline, whatever. When you have network available, you are going to sync up with other peers running the app on their computers. And what auto-merge does is it guarantees that once you've all connected to the network and exchange your edits with each other, you will all end up in a convergent state. So you all see the same thing. So that's sort of the basic underlying architecture we're working with. As I mentioned before, all sorts of schema problems pop up in this architecture. And so what we were shooting for was building this issue tracker and having different people be able to run different versions and still collaborate on the same data. So, if I'm running version 5 and you're running version 2, we should be able to open up the same software project and look at it together and work on it together. Now, there might be differences in how we see the data because the software might have changed in that time. But the goal is to do the best effort thing to maintain as much compatibility as possible, even as the software changes. And this includes even, as I'll show, sort of spanning changes that would typically be considered breaking, because yes, the data has changed in some irrevocable kind of way. But we kind of want to glue as much as possible between versions.
So just an interesting point here that I think is relevant here. Having worked with two different templating systems, so WordPress uses a pull system where you have to put variables and content in before any data shows, and Drupal uses a push system where all data that is defined gets pushed through, usually in an ugly, unstyled state. But it means that, right, there are two very different approaches, one of which being, well, at least you can see the data. So that might actually be something to think about at the display layer as you think about this.
Yeah, that's an interesting connection. Yeah. And there might be some stuff in a bit that relates to that. So I want to start with a pretty kind of simple example, which is we want to add a new property. So we decided we wanted each of our tasks to have a tags array on it. And so then in our code somewhere we have, code that looks like this, where we say, when the user does something, push a new tag onto the array. Now in pre-Cambria world, you end up with code around it that says, okay, do we actually have that array there? Maybe this document was created by an old version where that property didn't exist. So we need to initialize the array now as we sort of write this first tag onto it, right? And so what would be better is that when you load the document in this new code base, if there's just always an array there, right? And so Cambria helps you do that. Here's our first bidirectional lens. And that's the thing in the middle here. And you can see it's saying add a property called tags, and it's an array of strings. Pretty simple. And what it does is you can see on the left, we have, let's say this is a document we're loading from the old version of the code, and you pass it through the lens. And on the right side, you have a tags property, and it has an empty array filled in because that's the default value for arrays. Very, very straightforward. Now, one thing to note briefly is that this syntax in the middle is sort of this YAML-based syntax. We don't love it either. It's just the best we could get to in this project. Please don't judge the project too harshly based on the syntax. But so the point is here, we've done this useful thing. We've filled out a default value so we can once again sort of remove all that code and get back to the simpler thing. And again, this is the whole point, right? We've moved the complexity of schema compatibility out of the main code base. So that's a super simple example. Let's look at something a little more interesting. So we had this problem where we wanted to, we started with a checkbox next to every task that said, is this done? And that was called complete, and it had a Boolean attached. But we decided, actually, what we want is a dropdown with 3 possibilities. It's either to do, or it's in progress, or it's done. And so this is interesting, right? Because on the one hand, there's a fundamental incompatibility there. Like the Boolean and the dropdown are just different data types. They have different information in them. But there's also a very natural mapping between them. So this lens sort of expresses that mapping. So what does this lens do? We start out by renaming the field. We no longer want to call it complete. We're going to rename it to be called status. And then we also say something about how to map values across. So we say, if you have a document that says complete false, then map that to the status to do. If it's complete true, map that to done. And we also specify the other direction. So there's, and you could imagine maybe you could do shortcuts to sort of avoid needing to specify both directions in some cases. But the point I want to make here is this is not, there's nothing magical going on here. It's an extremely straightforward description of how to map data back and forth. And then at the other end, you have this to do with complete false. And on this side, you get status to do, right? Sort of what you would expect. But what you get out of this is sort of a really cool thing, I think, which is that these apps sort of automatically can collaborate. So what I mean by that is in this screenshot, I have two versions of the app up side by side. I have the old one and the new one. On the left, you can see is the old version where we have a checkbox. On the right, we have the new version where there's a dropdown. And we have compatibility both ways. So on the left, I can click that checkbox. And when I uncheck it there and I check it, it updates the dropdown status on the other side. And it also goes the other way. So on the right side, if I click the dropdown, set it to do, set it to doing, set it to done, you can see the checkbox on the left side updating in response. But the cool thing is, in each of these app code bases, each app is only aware of its own schema. So this is like a little snippet of the React UI for each of these apps. And you can see on the left, we just have an input with, this checked value mapped to doc.complete. On the right, we have a dropdown mapped to doc.status. Neither app really knows anything about it doesn't know about the other schema, it doesn't care. You just write code against the schema you're thinking about right now.
Something I want to jump in, and actually we looked at this presentation last night, but in the interest of trying to catch the questions and exceptions as people will think of them, you might be asking yourself, but wait, how would the old app be able to read data created in the new app, right? It wasn't around when the new data was written. And the answer is that these lenses, these translations, are actually stored inside the document in our implementation, or could be stored in a mutually accessible way in a production implementation. And that means that even a V1 app could open a V1000 bit of data as long as it can look up the lenses and then migrate it all the way back. V1000 doesn't have to write V1 data and then tediously migrate it forward. It can write data in its own native format. It doesn't pay any performance cost. And it just basically leaves a footnote somewhere that says, hey, here's how this relates to V999. And that has a footnote somewhere that says, okay, and this is how it relates to 998, and so on all the way back down. So V1 can still read that data. It might be kind of slow for V1 to read that data if it's not native, but it's a cost you only pay when you have long migrations and only if you have live collaboration between very distant things. Everybody always writes their native format, and they just leave clues about how to go back. And it doesn't have to be a line, right? It's a graph. So I could be writing V1000 of my app. Maybe Brooke and I collaborated on the first version of this app 2 years ago, and now she's done all kinds of things in her issue tracker to meet their organization's needs. But now we want to collaborate on an issue. Well, I can open up an issue in my version of the app, and she can open up in her version of the app. And the things that they have in common will work. We'll be able to speak our own language with the data, and we'll be able to use this graph structure to connect between each other. Now, it's obviously, if you sort of pass through a crux and then come back out the other side, you might lose some data. You might want to create a more direct mapping for either performance or fidelity reasons. But you don't have to. You can choose to opt into that when you need to. And if we do create a mapping, then anyone else who opens that data will benefit from it. Maybe somebody who forked from me would be able to take advantage of that shortcut across. And so anyone can link in a new lens to connect up and improve the fidelity of translation.
This is like a long troll to trick us into using semantic web and linked data, isn't it?
Well, I think the great failure of semantic web is that it didn't have schemas, right? There was this concept that somehow people would get value out of embedding this sort of metadata into things, but there weren't apps that consumed it. And there was this great complex process of agreeing on schemas. And there's a fundamental property of public schemas I've found, which is it's either too specific to be useful for your case, or it's too general to be useful for anyone's case. And so I think the idea here is you just embrace having your own schema, and then later on you figure out how to relate that to other people's data. And that's the I want to say insight, but I don't think it's been proven yet.
There's a bit of a sidetrack, but and I don't know if I'm using the right terminology here, but in print, I'm assuming that there's no global check on this graph of lenses. Specifically, if you would go from version 1 to 2 to 3, and then now you write a lens from 1 to 3. So you have two alternative paths, they could produce inconsistent lenses, right? So there's no check on confluence, or if that would be the right property that you if you diverge, you would always be able to merge back to the same state.
Yeah, so I mean,
going to be checked.
What we promised both with Cambria and AutoMerge is that same data, same output. right? So if you have the same document with the same operations, with the same lens graph, and you request the same version, you'll get the same output. The question of like, there may be more than one way to map the data. We might disagree about how to map the data. I think a better articulated like implementation is possible. But for now, what we do is we use a Dijkstra path search. So we'll take the shortest path. If there's more than one shortest path, well, you get one. And like, yeah, this is an interesting problem. And we had a great conversation with a fellow who did his PhD on this stuff, where he went more into like looking at the universe of data sources that were already out there and so on, and talking about like costing different paths, and you could use heuristics, or you could, there's lots of like interesting opportunities for optimization here, but like sort of following the principle of Yagni, like take the shortest path. If that's not sufficient, we're going to revisit that later.
While we're paused a bit, Brent actually had something at the very beginning. Having options to lift this above the storage layer is so important for stateless systems. Is that one of the key insights to Cambria?
I'm not sure I understand the question. Peter, do you?
I think this is shifting it out of the one-off migrations, one-off like big bang like data movements. And like it's funny, again, this is so shockingly universal once you start to look at it. Those of you who have had the good fortune or misfortune, depending on how it went, to deploy a large-scale Kafka install, right? Like one of the core tenets of Kafka is like you have these message queues that are stateful and durable and persistent. You don't go back and rewrite history. That history is what happened. So then when you want to read your Kafka data, you know, there's a schema for this history, and then you have to replay all those messages. And so there's this incredibly mind-bending piece of documentation in the Kafka schema registry, which describes all the different like possible options for like queue message compatibility, like forwards compatible, backwards compatible, additive forwards, subtractive back. Like there's this crazy matrix, and then a sysadmin has to think like, which one do we want for this particular queue for every queue in our system? And you have to choose, and then you have, it doesn't actually give you schema migrations. It just explodes if you try and write something that wouldn't be forwards or backwards compatible. So now you're back in the hell of optional types. So like, you know, that I think the idea of not trying to change the past is a good one. And I think, for example, like in Postgres, which is a database I know a lot about, you know, on some level, there is a certain amount of capacity to read old data and translate into new forms, and to write old data into old forms. And they do that kind of behind the scenes at the storage layer. What we're talking about is exactly that. Generalizing is pulling it up to the runtime and saying, data once written should be left alone. It represents a record of a thing that happened. And if we can, in a performant way, translate this into what we need on demand, we know the type of the program we have. If we can know the type of the data that we have, then we can map the two between each other, and the rest is all ergonomics and developer experience.
All right, let's keep going with the demos. So getting back to this sort of Boolean to dropdown thing. Another thing, just to reiterate, is this is not a perfect data conversion. Like a checkbox cannot display 3 values. So there is missing information in the old version, right? That is unavoidable. No library can fix that. Now, if you're collaborating with people and people are getting confused by that, you can always send an email and say, everyone must upgrade to the latest version, and impose some centralized control on the situation, right? That's an available option. And so the point here is not to magically make things compatible that weren't. It's just to get as much compatibility as you could reasonably expect from the situation in an ergonomic way. And then you decide whether, you know, which is better, forcing people to centralize more on the same software or allowing for more divergence. It turns it from this sort of like compatible or not binary into more of like a spectrum of compatibility. One quick last example that's, I think, it's sort of a fun one we ran into that I think, again, is emblematic of typical things that come up in systems, is just like GitHub, we started out with one assignee for each of our tasks, and then we actually realized we wanted multiple assignees. And in this, you know, Cambria system, that's actually pretty straightforward to do. So we write a lens and we say we want to rename the assignee field to be called assignees. And then we just run this one command called wrap. And what wrap does is it takes a thing and turns it into an array of those things. So in this case, assignee was a string, so we get a string array out the other end. You'll see here, if you give it a document that says assignee is Bob, you'll get an array where that's wrapping that value. But again, this lens works in both directions. So here I'm showing a demo of the app. And in this case, I'm just going to assign one user on the left side, which is the old app. And you'll see on the right side, it just stays synced. And there's only one assignee, so nothing really, there's no real problem here. There's full compatibility. But this also works the other way. So now on the right side, I'm going to assign 2 people. I assign Alice, and then I also assign Bob. And you'll see there what happened was that on the right side, both Alice and Bob show up. On the left side, we only see Alice because she's the first assignee. So that's how the lens works, right? And again, that's not a perfect that's not a perfect mapping. There's information loss, but it's the best we can do. Okay, so hopefully those demos have shown you a bit of sort of what we mean by achieving this kind of better compatibility across apps. Now, in this next section, I want to dive more into how the library works under the hood. And the goal here, we sort of split it up in a way that we're hoping that you can, again, not necessarily download Cambria today, but sort of use these ideas that I'm about to talk about in your own systems in a variety of ways. And again, I think they extend beyond decentralized systems into all sorts of useful contexts. And so, listen with that in mind. So there's three parts to Cambria. The first part is the core language for defining these transformations. The second is the lens graph that Peter mentioned earlier about specifying how do these schemas and lenses connect together. And the third part is this structure that we came up with for storing documents in a way that you can simultaneously read and write to them from many different schemas at once. So we're going to walk through each of those in turn. All right, let's start with the lens language. So far, it's looked like what happens in this lens is that you give it a JSON document and it spits out a different JSON doc in a different schema, right? In fact, that's a little bit of a lie. That's not actually what's happening. Under the hood, we use this idea called edit lenses, where you're not translating documents, you're translating edits to documents. So what an edit lens does is you give it an edit to a data structure and it sort of transforms that edit so that it applies to a different related data structure. So here's an example. A rename lens is a pretty simple one to think about. We have here a lens that renames the property called name to be called title. And if you see on the top, we have this edit operation where someone said, I would like to set the name to Bob. Now, what happens when we send that edit through this lens? We get a different edit that says, I want to set the title to Bob, right? Because if you have another document that uses title for the field name, that's the edit that corresponds. And this works exactly the same way backwards. So if someone on the bottom here says, I want to set the title to Bob, that edit gets passed through backwards and it produces a different edit that says set the name to Bob, right? And so it's a pretty simple concept. It's just taking an edit and turning it into a different edit so that it will work correctly on the other document. Now, rename is a simple case. Here's another fun one. What happens with add property? Add property is a little bit weirder. So for the most part, if you have 2 documents, right, and you just added a new property on the other one, edits can basically flow back and forth between them verbatim without much transformation, except there's we have to think about how to handle the extra property. So so here, here we have some edit on an unrelated property like name or title. This lens doesn't care. It's just gonna, ignore that slide. Let's move on to this slide. So here's how we're gonna handle the new property. So the first thing we need to do is think about default values. That's part of the job of an add property lens, is to think about filling in that default value as we saw earlier. So if I create a new object at the top here, this lens is going to take care of filling it in with a default value so that the bottom reader will be able to sort of rely on that array being there, as we saw earlier. And then what about the reverse direction? Well, that's actually pretty simple. Whenever the bottom does anything to that field, here we set the tags array to be something, that just gets blanked out. On the top, it shouldn't produce any edit, right? Because that property didn't exist on the old documents. There's nothing to do there. That's how the add lens works. Finally, I'll show you wrap, which is that scalar to array lens. And this one's actually pretty straightforward too. We just have set assignee to Bob edit, which becomes in the bottom, set the first element of the assignee's array to Bob, right? And so I'm not going to walk through all the operators here, but this sort of gives you a sense of what's going on under the hood. Now, of course, you can represent a document as a series of edits. So you can always translate a whole document if you want. But there's actually a lot of convenient things about doing this formulation where you translate edits and not documents. For example, as I'll show in a bit, for just sheer performance reasons, if you have a bunch of peers syncing, and every time I get a new edit, I have to translate the entire document state. That's just a lot more work. It's a lot nicer if when I get your edit, I can just say, aha, I'm going to translate just that edit into the edit on my data structure and apply that, right? And there's other reasons too, but that's sort of the big one. Now again, from these lenses, we get three things. This is an important point of centralizing the source of truth about your schemas in one place. So in addition to this graph of runtime translations, we also get TypeScript types. Here I have an example of, we just ran that wrap lens I showed you. So we turned the assignee field into an array. We have a new TypeScript type that got output by Cambria that has the array in it. And in our code, we get the nice squigglies. So here we have a place where we used to have .assignee, and TypeScript says, hey, there's now an assignees field. You need to change your code. And so when working on this app, it was sort of this nice feeling where we would write our schema translation, and then TypeScript would just tell us everywhere in our code we needed to change. We would just change all those places, and then we'd be we'd have new code that worked with the new data. We also get runtime data validation. So again, this is an important point too. Like TypeScript types aren't enough. In fact, in some of Peter's earlier work with Pushpin, the team had explored having TypeScript types in the system to describe the data, which was good. But that doesn't help you when you load a document and it doesn't match those types. TypeScript isn't checking anything at runtime.
Yeah, we would just lie to TypeScript and be like, oh, no, trust me, I'm loading this like CRDT. It's this type. But then somebody else would like edit the type. And then your app doesn't realize that's possible. And then all of a sudden you just start getting explosions at runtime. And you're like, but I thought I had type safety. It was all a lie.
So what you also need is something you can check at runtime. So we have this JSON schema file, which is a standard for defining the schema of a JSON document. And you can run, whenever you load documents off the wire, you can check them against what you expect using a bunch of different libraries that do this. And if you get malformed data, in some cases, you might not be able to do anything other than error. But rather than erroring deep in the bowels of your program in a mysterious place, you can just immediately upon loading the data say, hey, this data doesn't match a schema for this particular reason. I'm going to give up. We even talked about the futuristic possibility of saying, hey, user, this document you tried to load is wrong because it's missing this field. Do you want to fill in that field to make it work? We didn't actually do that, but that's sort of a thing you could imagine. You really need to validate data early on here just to avoid errors and random places in the code. Okay, so that covers sort of the core language. Next, I want to talk about this graph that we've been mentioning. So it's a graph where the nodes are schemas, and every edge is a lens that connects those schemas back and forth with a translation. And as Peter mentioned earlier, what we did is, if you want to translate from this schema over to that schema, you just find the shortest path, and you take your edit or your document, and you just pass it through all those different lenses to get from one to the other. And the nice thing about lenses is you can just concatenate them. So any concatenation of lenses is sort of a bigger lens that does more work, more translations. So you're guaranteed to correctly get between these two schemas just by following that path. And again, as Peter mentioned before, we also stored this lens graph in our data layer in our example app so that any peer connected to the document could load the latest lens graph. This means that what you have to do is if you're writing to the document and you're about to write with a new schema that no one's ever seen before, it's on you. In addition to writing your data, you also need to write in the new lenses that other peers will need to read your write. So like you add, hey, I have a new lens here. I'm going to extend this schema out and add a new schema up here. You need to add that to the lens graph so that your peers will be able to interpret your writes to the document. And finally, part 3 of Cambria is this version tagged edit log. So this was the data structure that we used to store the documents in our system. And this was interesting. I think in retrospect, it feels kind of obvious, but it took us many iterations to get to this point of trying to crack this problem of the fundamental problem is the data can't be in just one schema at a time. It sort of needs to be in all the schemas all the time, because anyone could edit it at any point in any schema, right? And so we had these different ideas, like what if you stored like a copy of the data in every schema or all sorts of things. But we landed on this different idea. And here's basically the structure. What we store is a log of edits. It's an append-only log, essentially. And that's the raw log you see up at the top here. And what you do is when you write, you say, here's the change I would like to make to the document, and you tag it with your version. A version is just an identifier for a schema. It's an identifier for a node in the graph. In this case, it's like v1, v2, v3, but in practice, you could use like UIDs or whatever. And this log just accumulates. And when you go to read the document, what you do is you say, OK, I want to read this document in v2, let's say. You iterate through this log, and for each patch, you translate it from the original schema it was written in to the reader schema, in this case, v2. And again, all that machinery we just showed, like the lens language, the lens graph, takes care of all of that. So it's sort of easy to do that. And then you just play those edits forward as v2 edits, and you end up with a v2 document. Pretty simple. And again, the nice thing about the structure is that as the log grows and you get new edits from peers, you just translate those edits incrementally and apply them to your local replica, right? The last thing I'll mention here is that the auto-merge CRDT document library stores its data in a very similar structure to this with a log of edits. So what we actually did was integrated Cambria with that actual auto-merge edit log. So in addition to sort of having the schema transformations happening, auto-merge is also making sure that even if peers concurrently sort of edit stuff, and so different peers have this log in different orders, you're actually guaranteed to get conversion output at the end. All right, so to summarize, here's like how you should steal these ideas, and please steal them and use them. Some things you can do in any system: tag data with versions, so you have to know what version it's in to have any hope of translating it. Do not do shotgun parsing. Stop writing conditionals in random places and instead try to perform data translations and validations early in some isolated layer. And if you're in a decentralized system, it works pretty well to persist a document as just a log of writes, and also to transmit your translations alongside the data somehow so that older clients on older code can read new data.
Quick note on the shotgun parsing. Shotgun parsing actually comes originally from a security paper, because it turns out that not doing this right means that you tend to get really weird security bugs that people are very good at exploiting, where they can like double stuff query params in your URLs or otherwise abuse your system by looking for little cracks they can slip through where you validate in one place and not in another, or validate but then don't check a secondary field, and so they can just populate the bits that they want and exploit you. So it's a really valuable concept for security reasons, independently of all of this other stuff.
And lastly, I know we're coming up to the top of the hour, but quickly, some future challenges we're thinking about, things we didn't get to. First, the language is not complete. There are definitely more operators needed. And we don't claim that any migration on your data you'd ever want to do can be supported in this language either. Like, it's clear that there are some things that don't fit into this nice, clean framework. And so there's more thought needed in terms of how to handle cases where you might need to actually write some complicated code to perform a translation. We don't handle recursive data schemas, which come up sometimes. There's some more work to do around thinking about how conflict resolution happens in decentralized systems across related data structures. One challenge that we thought about is, can lenses go fetch related data from a database or from an API? We sort of currently assume all the data you'd ever need is available in the context of your document. But what if you need to go get data from somewhere? We've thought of cases where you would need that, and it's tricky.
We assume one document in, one document out, but that's often not exclusively the case.
The last thing is, this is not super battle tested yet, so we're interested to try it in more real scenarios and see what happens. We do have one team who builds this thing called FarmOS. It's an open source web app for managing farms. And they're trying to use Cambria to essentially, my understanding is that they have a bunch of data about your farm and they need to convert it between the format that their mobile app uses and the format that their like cloud Drupal app uses. And they were going to write a bunch of hand-coded stuff to do that translation back and forth. And then they decided maybe Cambria is like an easier way to do it. And so we'll see how that goes. Okay, maybe I'll just close with one quick last thing. So far, what we've showed you is different versions of the same app, right? Fundamentally, it's like the framing is like you are a developer iterating on an application. But there's also this related idea of mapping across applications that are similar to each other. So the problem I always come back to is, why can't I live edit a Google Doc in any other editor? I have to use Google's UI. There's no layer that separates UI from the data persistence there. And I think part of that, as usual, is business model incentives, but part of it is just technology too. Like how do you create a live editable data structure across multiple editors? I don't think we fully know the answer to that question. And one hypothesis we have is that these sorts of schema flexibility tools might help different tools work better together when editing shared data structures. So like if I have my own favorite text editor and it doesn't store data quite in the way that Google Docs does, can we still edit together by lensing across the two? One little demo I've been playing with is this little playground software environment where you can write Cambria lenses to translate between the data of different apps. So here I have this little like Google Docs with comments type thing on the left. And on the right, I have a Trello board. And what I've done is I've mapped each comment in the Google Doc to a board on this not real Trello, fake Trello clone. And sort of as a user, I can write these lenses to specify, here's how these data structures should fit together so that the edits flow back and forth. And this is just a early experiment, but I think it's a fascinating sort of problem statement to explore, and maybe these sorts of tools would help.
Just to expand on the philosophy here, right? Like, it's honestly shocking how pathetic we are as an industry at building tools. It's humiliating. If you're a carpenter, you don't have to turn up to the job site and use somebody else's saws. If you're left-handed and you need left-handed tools, you can buy left-handed tools. If I'm a writer, right? We're working with a writer who helps us edit our posts sometimes. We make him use GitHub. It's awful for him, right? If you join a company as a freelancer or a contractor, you don't get to use your tools. You don't get to use your editor. Somebody tells you to use Google Slides. You don't know how to use Google Slides. Today, you're learning how to use Google Slides. We do not have portability of tools for thought workers. We force people to use Jira or Asana or Trello or whatever garbage somebody chose and doesn't have the energy to move off, and drag ourselves through the muck of constantly feeling uncomfortable and out of place and out of sorts because we don't have any support for tools.
Yeah, and what we actually forget in many places, like the reason that there are 9 billion to-do apps, never mind issue trackers, is that everybody needs a slightly different shape, including the shape that works for me in my private log of to-dos that really should just merge. So this is one of Brooke's ideas where she's like, what if we just make a universal graph of to-dos where everyone can work on it? So those are some of the things that we're exploring at
and the answer
Fission.
is because any schema that would be sufficiently universal to support everybody's to-do app would be insufficiently specific to support your to-do app. And so this is the fundamental idea behind Cambria. What we want is not just to moderately improve compatibility between different versions of the same app. Yeah, that's great, fine. What we believe in is the promise of a Cambrian era for software, a world where all of us can have the programs that we deserve, that meet our needs, that serve us as humans. But we can't have that today because we have singleton, factory, monolithic apps. There's only one Slack and you don't have it. You can touch it, but it's not yours. They can change it. There's only one Twitter and you can touch it, but it's not yours. I want to have my tools on my computer. I want to have agency over them. I want to choose what they do and how they work, but I don't want to give up and go back to the world of like Windows 3.1, like, oh, I'm on the wrong point release. Oh, I didn't download the new thing. Oh, we can't talk, right? We want to have the power of the cloud. We want to have the promise of the cloud. which is instant access to all your data, instant collaboration with everyone on Earth on all your devices. We don't want to surrender agency over our tools and be at the mercy of corporate interests to continue to grant us access to the things we need to do our jobs under the aegis of like freemium marketing to the companies that employ us. That's a sad and sorry state of affairs. And that is the default for our industry. And it does not need to be that way. We can do better.
I have a question.
Let's take that pause to do a round of jazz hands and thank you. Amazing. Geoffrey and Peter, thank you so much. I think a lot of brains exploding here. David, I've got you next up in queue. So super awesome to capture a PVH rant on live video, which I'm looking forward to spreading widely. So a lot of this stuff is, Peter is actually an advisor to the team at Fission. We're trying to do a lot of these things where every user has a data store where apps write into. So, you know, Brooke has had a lot of discussions with Peter on auto merge and Cambria, and James is leading some work in our WinFS database design that we'd like to bake a bunch of these things into an app building system. So that's our interest. And this is our jam. So if anyone has other talks or topics around like this, we do these things every week. So please do contact me. I'll send out a follow-up email to everyone on that. Okay, David, please ask your question. Go ahead and unmute yourself.
At some point you mentioned, you know, the declarative language that's in YAML to do these back and forth transformations. That kind of reminds me of like Datalog and Prolog, because you're trying to do, if you want to join other documents, right, you could, in theory, write that as a Prolog program, get your variables out, and that ends up being your transformation pipeline. And Prolog does do back and forth. If you write a predicate, it can, you know, fill in the blanks if you give it enough of the, if you ground enough of the variables, which is similar to this, right? Like you have the input and then you do some transformation and get the output. But if you had the output, if your predicate was written in a way that could give you the inputs, you could get something else out on the other side.
There's a bit of a connection there. I do want to like point out, like, at least in what we've done so far, like declarative is a fuzzy word. In the Prolog sense, it means that like turning your declarative spec into actual results is a really complicated process. That's like you're running a search process, right? It's not like a simple compilation. I wouldn't go that far with this language. Like we say declarative because what it means is you don't write two things for translating one way and the other way. You write one thing and it does both ways. But it's not like there's any fancy search process going on under the hood. It's just it's a relatively simple transformation that goes on from your code to what actually happens. And so there might be a loose connection, but I think I just want to say that because you know, don't imagine that we've written thousands of lines of crazy compiler code to run these lenses, right? It's really not that complicated.
A couple of other points. One is it is vital and essential that this is not a Turing complete system. It only does what it does, which is that it is a bidirectional data translator. This has so many advantages, not least of which is like you can do things like hopefully guarantee termination. Also, because it's constrained, we want to say every possible lens stack you create is bidirectional, or at least that fails in like well-defined and understood ways that are predictable when you write it. There should be no surprises when you use this, right? Like not all migrations will be bidirectional. Like we can imagine adding things where, oh, this is a required field, there can't be a default value. And if you try and load data that's from older versions, throw an exception. But older versions could still drop that field and continue to work with the data, right? So you can imagine there being another good example, like this is not a politically neutral territory. There are data migrations that are technically feasible, but are not culturally or socially safe or reasonable to do. You know, you could have a license plate machine that could stamp, you know, one format of license plates, but not another. And if you throw the wrong data and it would explode, but maybe the new ones can do both. Or vice versa. I think gender is a really good one where old legacy systems might model gender as like a Boolean or you know, just a two-value enum, and a more modern system would support like a broader perspective on how people self-identify. It would be harmful, specifically harmful to people, potentially even a violation of their rights, depending on your jurisdiction, to map them back to an arbitrary distinction in that old system. But you can map all the old data forward just fine. So I think it's really important to remember that like all of these technical systems are embedded in human and cultural systems, and that it's not enough to say we can do these things technically and that's sufficient. We need to think about the bigger picture. The last thing I'll note is like whatever's happening in Prolog is fine, but like Prolog is not the future. I'm sorry to report. We should definitely rummage through the the pockets of that corpse in the alley and take all its best ideas. But like the future is not a world of Prolog. Muhammad must go to the mountain. We're writing TypeScript now. I've spent my entire career trying to escape the JavaScript ecosystem, and I will continue to try to reach escape velocity. But if you want to have an impact on the field, you got to write JavaScript, and that's just how it is.
Brooke, and then Marc-Antoine. Did you have a hand up, or you were just clapping?
I was clapping on the technology is not politically neutral.
Okay, amazing. Marc-Antoine, please.
Indeed, on the socio-technical embedding, I agree totally. I've been looking at another system, and I'd like to have your comments. It's called Underlay, and it does schema mapping through an intermediate of individual, almost triples, right? Well, pretty much triples, semantic triples. So the idea is that instead of translating from a schema to another, you have this soup of features, which are individual, and then you lift those soup into a schema. So what's your feeling about this other approach? Have you looked at it, and how it compares to yours? Certainly, it allows a lot of very interesting algebraic transformations between schemas.
We've given this some thought, and I think Brooke actually has a similar kind of concept on the go as well. And we were talking about this yesterday.
We're talking.
And so I think it's really compelling. I think this will work. I think what we're doing will work, and I'm not sure if that will work, which is a very a deliberately weak position to take. It's a domain question, right? Which is like in the conception of the world that led us to this implementation, you have programs that have types that are strict, right? Like your program is a to-do list. It has data that follows a certain shape. There's, you model down from the way the app thinks about the data, and then you think, how can I use this data in other places, and what kinds of relationships and conversions do I need to make? And so when you follow from that, you wind up in a Cambria-like place. I think when you build up from like a soup of data in like the RDF semantic web sense, you approach something more like what you're saying, which is I have all of these facts, I have all these assertions, and now I need to see whether or not I can materialize this into useful types. I think the challenge is that broadly, it's very hard to maintain or guarantee integrity because you just have so many possible like underlying state configurations, and relatively few of them will produce valid outputs. So like in sort of a category theory sense, right? Like in Cambria, you have an abelian group, which is that like all valid inputs are converted to valid inputs in the other systems, right? Every move is legal that you can take. Whereas in this model, I'm not like, maybe it can be done, but I have not managed to reason about it. Similarly, like our auto-merge CRDT is document oriented. So you always have a tree structure of data as input. So you can always produce a tree structure of data as output. We've talked a lot about going to like more of an event source, like you just write data and then try and materialize documents out of it, but will it work? I don't know, maybe. Right now we're making headway without it. And so please leapfrog our work if it works.
Yeah, I do.
Geoffrey had a comment.
Yeah, I have a comment on the validation. I think I agree that the validation is at the schema level, but I also think that building schemas from scratch allows for multiple schemas, each with their own validation constraints. And then you can look at your soup as, does it follow this schema? Does it follow that schema? And for me, that is actually a positive goal.
Yeah, I think it would be better if it can be made to work. I think it's a generalization of our approach, and I'm interested in it. But we have enough juicy targets in front of us and problems on the horizon that I'm just kind of like, well, hopefully somebody will take our work and extend it. And if that works, so much the better.
Yeah,
thank you for the comments.
I wanted to add one thing on this, which is I do wonder, like, all of the examples I've seen of these triple stores have been like, and including the underlay, have been sort of open knowledge graph style things where it's like we are collecting we're creating this collection of facts about the world, and it's like it's an encyclopedia right? It's like academic publications and their authors, and it's lakes in France. And I think I do wonder if that's a different problem to solve than like we have two different Google Docs editors that we want to be collaborating between. You know, and that's personally my frustration with the semantic web has been so much focus on building the encyclopedia as opposed to thinking about like applications, which and maybe there's some differences there.
Yeah, well, there is all this work on, you know, Solid has been trying to turn semantic web into an application.
Marc-Antoine, will there's so much more to go into here, and we had Solid last week, so I'll actually pass it on to Alex to ask another question.
It's cool.
I was wondering what would look like to implement Cambria in other programming languages. TypeScript definitely in JavaScript has some advantages by being, you have proxies in it, you're able to reroute field accesses easily. What would it look like to do this in Java or in C++?
Do you want to take that, Geoffrey?
Sure, I can take it. So one nice thing about one of the advantages of we could have embedded this language in JavaScript as like the syntax essentially. We decided one of the reasons we made this weird YAML syntax was to make it more language independent. So you could imagine a Cambria runtime in another language that can execute these lenses fine.
They're very easy to execute as well. This is like not hard at all.
It'll be easy to port. You do have to, you know, have JSON-ish data, so like maps and lists, but every language works with JSON, so I think that would be fine.
Also, notably, we are not using proxies here. Like there's just a function, you give it the data that you get off the wire, and then you're like, I want it in this format, and then it takes the data and it produces the data in the new format.
Well, we do some change recording. Yeah, we don't use we currently do, I believe in our current implementation, we just diff. So when you when you edit a Cambria data structure, all we do is you do your edits, we diff old versus new and generate a series of edits. It'd probably be better to use proxies. I believe we don't do that yet.
Well, it also, I mean, proxies are something many developers find ergonomic, and that's how AutoMerge works. And you know, that was probably my bad idea or somebody at InconSwitch's bad idea. And it's ergonomic, but it also leads to like unreadable stack traces and very confusing like error states. I think a more explicit like functional like immer style, or not immer style, but like a immutable JS style interface in many ways would be superior because it's more explicit about what's happening. But you know, there's always this tension between like make it simple and make it easy, and so we're always kind of like wending the path there. So it's absolutely nothing JavaScript specific about this project.
You need some way of when someone edits the data structure, tell Cambria what changed, and yeah, there are a lot of ways to generate that list of edits.
Antroneg, if I'm saying your name correctly, did you? Yeah, go ahead.
Oh,
and
sure.
Jiri, I'll get you next.
Hi, great. Yes, I was looking for the hand raise, but I just see thumbs up and stuff and reactions. Yeah, I want to say, yeah, this is really great work, and I'm glad that these fundamental problems are being recognized of interoperability. And I think Peter's rant was great about how devastatingly bad our tools are for communities of people. So we built a system quite similar to this a while ago. It wasn't remotely as good as Cambria, but it had the basic concepts of lenses connected together in graphs that could find their way between schemas that were freely arranged. And it was, although it was a terrible system, it was good enough to sort of shed light of some of the fundamental problems that these systems are going to run into, because I'm confident these systems are going to be built and become widespread. And I just wanted to highlight a few of these half bricks in the path of the bicycle of history that are coming our way, which is the notion of composition. So I noticed, yeah, the big problem is, right, there isn't a single schema. We've got a distributed, decentralized system that people can write to from anywhere. Now, the bigger problem coming up is that we don't even have separate, isolable ideas of what a schema even is. So a problem coming up is what happens when two members of the community want to compose their schemas. So I saw Peter commenting in the chat about how Lovecraftian and horrific it was to imagine operations which act on lens documents, but in fact the first thing people want to do with lens documents is compose them, and they don't want to compose them end to end. In the peripheral sense, they want to compose them across their surfaces.
So specifically the problem with writing lenses on lenses was trying to read them and having things that say like source, destination, origin, target, destination, you know, and then you're like, okay, wait.
No, yes. We
you have type checking, which makes life better, but it was like just excruciating. And
Sure.
so just speaking to recursion and composition of schemas, that's a real problem that we didn't solve with Cambria and isn't in the current implementation. It is, however, in JSON schema. And there's another member of the sort of interested party community, a guy named Johannes Schickling, who we drew a lot of inspiration from his startup Prisma, which provides type safety for SQL databases, which is a great project, and I'm an advisor to them as well. So full disclosure there, but the reason why is I saw this thing, I was just like, I want that. And then when we did Cambria, I was like, let's do it like that. But he's been also experimenting with implementing this stuff, and he has explored some of that. It seems fine. JSON schema has support for it. It's like fairly obvious. Oh, obvious is the wrong word. It seems tractable to add those features to this system. And it's actually where you get into, I think, really interesting problems, and maybe is what you're pointing at, is like, if you're embedding sub-schemas inside your data, and then those have versions as well that can evolve independently and have both old and new. So I have, you know, I have a project and I have a task, and I've got some V7 and some V45 tasks, and also some like orange tasks from Geoffrey, and then I want to render my app. Hopefully, yeah, I think these things are doable, and the composition, I agree, is very important. The way we cheated actually is noteworthy. The way we cheated is we used separate schemas, and then we put them in separate documents with links between them. So each of those could evolve independently, and they could be heterogeneous. And then we compose them using React components. So the project would be a React component with a list of subdocuments, and then a task is a document inside that.
Can you express that composition in your dialect of lens documents itself?
Not yet, but it should be doable. And Johannes has been experimenting with that in his project schema layer, which he hasn't released, but I've seen early results, and it is.
That's great.
I think there are interesting UX questions, but it does seem doable.
I think that there's a whole pile of things here where the stuff that, so technically, I think I said building the new OpenDoc as part of this. I saw some of Geoffrey's post and then backtracked and went, oh, he's working with Peter. Let's talk. And, you know, we're thinking about some fundamental types like, let's do some calendar stuff and let's do some to-do stuff. And then you immediately fall into VCal and you hate your life. And you're like, you know what, we'll just build it up out of YAML or bits of JSON, which certainly isn't any worse than the standards we have today. Jerry, you had a question. Go ahead.
Just quickly, I see that that within Fission and Drive and things, what you can do is actually save, just like you said, the version. Don't save the version. Save somehow link the CID of the right version of the program,
Yes.
and actually do the mapping that you're talking about.
Yes.
Cross, you know, not real time, but when you want to actually upgrade.
Yes. So
I think that Fission really gives you this opportunity to actually, okay, you do your own thing, but with Cambria or some that kind of mapping, we can actually do the upgrade.
Yes. So
what
for
I'm trying
convenience
to say.
and legibility, Geoffrey used V1, V2, V3. But in our implementation of Cambria, the versions are actually hashes of the contents of the file.
Exactly, but it could be the hashes
an
of the
IPFS
program.
CID to, yeah. Oh, and the program, well, that you want the
That's
hash of the
possible
type.
in Fission.
Yes, yeah, totally.
Yeah.
And there's also, and I want to flag, we didn't get into it, but one question several people have asked us is like, wouldn't it be better to orient around the types and make the types explicit? And like, when you think about database migrations, they kind of suck, which is like, you have this implicit state, which is the before, and then you do a tiny little thing, and there's an implicit state, which is the after, and that's kind of hard to reason about. Wouldn't it be better to just edit the type and then run a shell script that like says, generate me a new proposed link in the graph, and then you look at it and you go like, yeah, that looks right, or oh no, that's actually not a field right now, and removing that field and adding a new one. So I think there's opportunities to improve the ergonomics here, and you know, please do. But yeah, tying this stuff to a content address file system is very interesting. By the way, several people asked about CRDTs, and we may not have time to get into it, but you can grab me. AutoMerge and YJS are two good CRDTs. The first one is ours. YJS is the other big competitor. There's a website called crdt.tech. I think if you're reading academic papers about CRDTs but not trying to develop one, you've probably taken a wrong turn along the way. A lot of this stuff is buried in like academic jargon, and it should be useful, and that's what both YJS and AutoMerge are trying to do. Yes, it is an edit transformation language rather than a schema transformation language, but I think they are a dual of each other.
Awesome. I am going to hit the stop recording button. Thank you so much, everyone. That was fantastic.